So my name's Nick Cox. I've been involved in heat pumps for longer than I care to remember, but I reckon it's about 35 years. First question, what is a heat pump? Well, in actual fact, you've all already got one. The fridge in your house is a very simple heat pump. It extracts heat from the food at relatively low temperature and dumps it into your kitchen at a higher temperature. Now, if you imagine putting the inside of your fridge in your garden and keeping the back of your fridge in your house, you would then be extracting heat from the garden and putting it into your house. And that is what a heat pump does. It's simply a refrigeration device where we make use of the heat rather than the cooling. So the simplest one of all is the one that I've got in my study. I've got a brick-built building at the bottom of my garden that I use as a study.
Sorry, Nick, are we supposed to be seeing something?
If you're not seeing something, then it's not working.
No, okay. We're seeing you.
Ah, yeah. Right. Okay, so the screen share didn't work. So
I was trying to work out how to type that to the chat group from my phone.
Right.
Or it was the PowerPoint that didn't work.
So, can you see
the PowerPoint now? We can see your screen now.
Yeah.
Right.
Screen sharing.
We will go back. So. Right. Now, go back. Go back. Right, have you all got a slide that says Nick Cox with a purple background? Right, okay.
Yes.
Start again,
yep.
Great. So that's me, 35 years with heat pumps. There's the domestic fridge that I've just described to you. And here is the heat pump in my study. So on the left-hand side, what looks like an air conditioning unit, and on the right-hand side, two simple holes through the wall. One draws air in, the heat pump extracts the heat, and then the other one discharges it. We got more people wanting to join us. That's great. Madla's joining us. Alex is joining us. And fantastic. Hi, Alex. Hi, Madla. Right, so we're looking at the simple air-to-air heat pump, which I've got in my own study. Draws air in through one grill, extracts the heat, and discharges it through the other. In the summertime, you can also use it as an air conditioning unit. And if anyone's ever stayed in a Premier Inn in the city centre, you may well have had one of these in your room. So I get rid of that, and we're going to the next one. This is the other type of air-to-air heat pump that you will see very frequently. You have an indoor unit and an outdoor unit, and you connect the two with refrigeration pipework. Now, this is actually quite a skilled function that does require a properly qualified engineer. Whereas with the previous example, if I'd have had the right tools, I could have done it myself. But this is the far more common type of air-to-air heat pump that you will see. The problem with the air-to-air heat pump is that when you need the heat the most, you've got the least heat in the outside air. And just like the cold box on your fridge, it needs defrosting on a regular basis. Every time the coil that extracts the heat ices up, it needs to go through a defrost cycle, and you get no heating in your house. So they're not as efficient when you need them the most. If we go for the water source heat pump, you will get a constant temperature all year round. What we've got here is a borehole which extracts groundwater from maybe 30 to 100 meters below your house. And that water is at a remarkably constant temperature of 11 degrees centigrade all year round. So you can extract that heat quite easily. You then need a second borehole to put the heat back under, to put the water back under the ground again. Much more efficient as a heat pump. The disadvantage is that you've got to run this pump to pump the water from deep down and return it into the aquifer. If you get a drought condition and the water table drops, there's always a risk that you lose your water supply. And particularly around us where we're in a chalky aquifer, you can get a blockage in the pump and then the pump needs maintenance. So the maintenance costs can be quite high, and there is the risk of reliability if you lose your water supply. So most people, oh, that's what one looks like. It really doesn't look any different to a boiler. It can sit in your kitchen, it can sit in the garage, and it makes a noise like a fridge freezer. Just a gentle hum from the compressor. But most people don't use the water source. They prefer the ground source because they are more reliable. This was a heating system we put in for a school in Buntingsdale in Shropshire, and we've got 2.8 kilometres of plastic pipe buried in the field next to this school, and the school only had 6 classrooms. So it was a massive piece of engineering for a relatively small school. And we pump antifreeze through this pipe all year round, and it's much more reliable than a water source heat pump. But you've got this constant drain on the energy efficiency that you're having to pump antifreeze. And this is what the circulation pumps look like, much bigger than the circulation pumps on your central heating system. And they really are a drain on the energy efficiency. These pumps are installed at the B&Q store in New Malden, and they weren't getting the energy efficiency that they were expecting. When we did some research on it, we discovered that the circulation pumps were drawing more electricity than the heat pumps, and we were completely wiping out the benefit. But there is a solution. We called this talk Heat Pump for Beginners, but this is about as advanced as it gets. This is a thermosiphon or a heat pipe. And it's a tube, typically 2 to 3 inches diameter, 50 to 60 mil in diameter, made of steel, and it can be up to 100 meters long. So it's a fairly deep borehole that you need in your garden for one of these. We put a vacuum pump on the pipe, so it's completely under vacuum after we've installed it. And we then introduce carbon dioxide as a liquid. The carbon dioxide falls to the bottom where it extracts heat from the ground, it evaporates, and the relatively warm gas goes up the center of the pipe. We condense it in our heat pump, and then the relatively cool liquid drains back down the wall of the pipe. Completely zero maintenance, zero running costs. That will work at maximum efficiency for as long as the pipe lasts. We can design that pipe to last 50 or 100 years if necessary. And this really is the future for ground source heat pumps. It takes away all the running costs, all the reliability factors. There's companies in Austria that are really good at this now, and they use it a bit in Scandinavia. But as with many of these things, it's not that commonly used in the United Kingdom. The other big problem with heat pumps is that they don't work particularly well with conventional radiators. And most existing properties in the UK use conventional radiators. If your radiators have been designed properly in accordance with EU standards, we've got another person joining us, then they will have been designed for a 75 degrees exit from the boiler, 65 degrees return. That's standard design conditions. Oh, Hillary coming too. Standard design conditions for radiators. A heat pump will typically work at a 50 degree flow temperature and a 42 degree return temperature. And that will produce 57% less heat than a gas boiler. So if you want to put a heat pump onto an existing radiator system, you either need to super insulate your house to cut your heat loss by 57%, or you need to double the size of your radiators. And this is the biggest barrier to the installation of heat pumps in conventional UK houses. And if anybody read the Labour Party manifesto and the Green Party manifesto, they were talking about putting heat pumps into existing buildings, and they hadn't thought through the detail. I did get in touch with both, and they didn't really want to engage in a detailed discussion. The other problem with conventional heat pumps is that if you use them to produce your domestic hot water, you do run a risk of Legionnaire's disease. If a heat pump will only heat the water to 50 degrees, you will not kill the Legionella in your water cylinder. You have to heat that water to 60 degrees to make it safe. Now, if you prefer to shower rather than bath, it is really important that that water is free from Legionella. The water that comes out the shower head, the whole time you're in the shower, you're breathing in that aerosol. And if there's any contamination in that water, you are putting yourself at risk. And they really play down that risk, and it is a serious one. Every bit as serious as coronavirus. If you get Legionnaire's disease, you are not well. So why would you want a heat pump with all these problems they throw up? A very good reason for having a heat pump. For every kilowatt of electricity that you pay for, you will be drawing at least 2 kilowatts of heat from the environment. So in many ways, we're reversing global warming. We're taking heat from the environment where we don't want it, and we're putting it back into our houses where we do want it. So it really is a fantastic technology if we can get it right. So let's look at the economics. Sorry to give you a chart. You can have a copy of this later if you're interested. This is an energy cost comparison valid from April of this year, which is about as up to date as I could get the figures, based on a small 4-bedroom detached house, fully insulated to the latest standards. Now, if you're off the gas main and you're unfortunate enough to be using off-peak electric storage heaters, it'll be costing you about £1,430 to heat your house. If you've got an oil boiler, you can cut that to about £1,120. And if you use wooden logs, which nowadays they insist on calling biomass, you'll get that down to about £1,118. LPG, liquid petroleum gas, is a little bit cheaper, and coal, surprisingly, a little bit cheaper still. But if you're lucky enough to be on the gas main, which most of us in towns are, your heating bill should be working about £494, less than half the cost of those alternatives. So when we look at heat pump running costs, your conventional typical air source heat pump, like the two that I've showed you earlier, the savings are absolutely negligible, maybe £20 a year, and you'll never get a payback on that. If we go for the very high efficiency air source heat pumps using the best refrigerants, we can trim about another £50 a year off your running costs. But you do need to go to the ground source and the water source heat pumps to start to get your costs down. And because of the pumping issues that we discussed earlier, you're not going to save much with your typical ground source heat pump. But if we go for a fully optimized system, we can get your running costs down to about £300 per annum, which doesn't look a particularly good deal. And the main reason is that gas is still too cheap in this country. Now, ever since we bought North Sea gas on stream, we've priced it deliberately low to encourage people to use it. So what we have is a grant scheme to make it look more attractive. And this is the domestic renewable heat incentive. And there are 4 heating options available to you. The first one is biomass. And this is the old cash for ash scandal that caused all the controversy in Northern Ireland. The government will actually pay you 7 pence per kilowatt hour to burn logs in your solid fuel boiler. And personally, I think that's scandalous, but there we go, it's still available. And to be perfectly honest, it's a really good deal and we should go for it. Alternatively, if you put in an air source heat pump, the government will pay you 10.85 pence for every kilowatt hour of renewable heat that it produces. Now that is a fantastic deal. It will not only pay for all your heating costs, but it will give you enough profit to pay for the heat pump in about 7 years. And because ground source heat pumps are more expensive than air source heat pumps, they've doubled it. 21.16 pence per kilowatt hour is a phenomenal amount of money. You'll be getting checks for thousands of pounds from the government for this, and it really is worth having. And you can put in a solar thermal system as well as a ground source heat pump and claim the grant for both. So I would put in the ground source heat pump to do the central heating only and keep it at a nice low temperature. And I would go for the solar thermal to produce the domestic hot water at a nice high temperature to avoid the Legionella. And I'd put in an immersion heater to boost the temperature in winter if there was ever any risk of Legionella, which there shouldn't be. The renewable heat incentive will give you a check every quarter from the government, and they will pay out for 7 years, by which time you'll have paid for the installation and you'll have had free heating for 7 years. It's such a good deal, you wonder why we haven't all done it by now. And one of the reasons why we haven't done it is there is a massive bureaucracy to go through to get the money. The first thing you have to do is get an energy performance certificate for your house. Now, if you're going to sell your house or rent it, you have to have one of these anyway. And it contains a lot of useful information on how to save energy. If the roof insulation isn't up to scratch, they'll point that out to you. If for any reason you haven't got cavity wall insulation, if the double glazing isn't up to standards, it is worth having this done. It will cost you between £60 and £120 a year. And personally, I think that's, per certificate. And personally, I think that's too cheap because you're not going to get a lot of consultancy for £60. When the average accountant charges £120 an hour, you're expecting a trained consultant to give you several hours work. It's not great, but nevertheless, we've got a lot of them around here. These are all the certified assessors in our locality. I was really surprised how many there are. I phoned the first one up this morning just to see what he was like. Ever such a friendly, helpful chap. But by the time he's driven out to your house, done a survey, gone back home and produced a report, you're not going to get a lot for, I mean, he quoted me £90, but by the time he's done his survey, he can't really give you more than an hour's work. If you are going to do a heat pump, you want this guy on side helping throughout the project. And I think you need to be prepared to pay a little bit more for that. In order to qualify for the grant, you must use a micro-generation certification scheme certified installer, and you must use an MSC certified product. And that's an absolute must. And that does limit your choice of installers, and it does limit your choice of products. So I went on their website today, and we've actually got 3 certified installers in East Hertfordshire. We've got a company in Ware, Eco Power and Lighting. I've been on their website and they look quite good, to be honest. We've got a company in Sawbridgeworth, which doesn't even have a website, which is a little bit concerning. But nevertheless, if he got himself certified, he can't be too bad. And we've got a company in Buntingford. I went on their website. It doesn't look like heat pumps are really their speciality. But nevertheless, they've done the training, they're on the course. If you are getting a heat pump, I would recommend getting at least 3 quotes. And if we've got 3 installers in East Herts, I would get a quote from each. Next thing to look for is the most efficient heat pump you can find. As with all domestic products now, we have an energy labelling scheme for heat pumps. A++ used to be the highest level. We now have A+++. So do check for your efficiency. The Energy Saving Trust runs a very good database of energy efficient products. It's well worth checking the heat pumps that they've got on their list. Most of the heat pumps are going to be manufactured in Europe, so do look out for the European quality label for heat pumps. We do want this to last. And my favorite is the energy technology list. It's a lot easier to use than the other lists. It's been around a long time. There's a good selection of heat pumps on that list. So you'd think that we'd overcome the problems and we were all set to go. Unfortunately, the Achilles heel with most heat pumps is the refrigerant. They tend to use high global warming refrigerants. The most common is this R410A, which causes 2,100 times more global warming than carbon dioxide. To put it in perspective, if a heat pump lost its refrigerant, it creates the same amount of global warming as getting an aeroplane to Kuala Lumpur. They really are awful. The 134A that you will find in some heat pumps is still 1,400 times worse than CO2. And my favorite refrigerant, R290, is only 3 times as bad at global warming as carbon dioxide. And this is the refrigerant that you need to be looking out for. And absolutely none of the heat pumps on the approved list use environmentally friendly refrigerant. And there's a very good reason for this. It's called the F-gas lobby. The chemical industry has been hugely successful at preventing us from using environmentally friendly refrigerants. There's so much profit in these refrigerants that they will do anything to stop us using anything other than what they produce. They sit on all the industrial standards committees, and they just make it really difficult to use environmentally friendly refrigerants. But that doesn't stop me from trying. I found this heat pump made in Austria. It's the most efficient heat pump you'll find. It produces 6.7 kilowatts of renewable energy for every kilowatt of electricity that you pay for. It uses natural refrigerants, and it sits in your garden with this thermosiphon, so there's no pump. Absolutely brilliant product, and it's got the A++ energy rating. So a week ago, I got in touch with them, so I'll have one of those for my house. Still no reply. If you were an Austrian heat pump manufacturer just coming out of COVID shutdown, with all this Brexit nonsense going on, would you really want to supply the UK market? Probably not. So what I am going to do is keep badgering them, and possibly, if I've got the time, I will become the UK agent for the product. So I think it's brilliant. I've rushed through this because we're running out of time. These are the links to all the slides that I've put up. So all these websites that you should be checking out, there's a list of them. And I was supposed to leave 5 minutes for questions and answers, so we'll have to rush here, but thank you ever so much. So I'm going to come back and have a look at you if I can. There we go. Thank you very much. So anybody got any questions? Most of you are on mute by the look of it. So if anyone's got a question, you'll have to unmute yourself.
Hi, Nick. I have a question. In terms of actually putting in the infrastructure to do the heat pump, is it quite difficult to do in an existing house? Like, say, for example, you have a standard suburban garden. I'd imagine the space available makes it quite tricky to physically get the bore in. Are there ways around that? Because I know obviously for a new build it'd probably be quite easy, but not so much in an existing house. Yeah.
So when they drill this borehole, they need to get in a pretty big piece of kit to bore the hole. And the bigger the bit of kit, the quicker they can bore the hole. We did one in Ladbroke Grove a couple of years ago. We had to get down 100 meters, and the piece of kit he could bring in was so small it took him 2 weeks to bore the hole. And we had 2 skips of spoil that we had to take away, and you have to pay for the spoil as waste. So yes, if it's new build, you're laughing. It can all be done as part of a build project, but it is more difficult in an existing build, which is why people tend to go for the air source, because it avoids that. But one thing to watch with air source, if you're very close to your neighbours, they can be a bit noisy at night. As with ground source, it's quiet, the neighbours won't hear it.
Can you hear me?
Hi.
Could I ask a question?
So I didn't quite catch that.
So could I ask you a question?
Yes, please.
I was just wondering how big is the thing that goes in the ground, and maybe you could go in a front garden rather than a back garden.
The borehole is only 65 mil diameter. They probably drill 100 mil hole so that they can get the pipe down. So front garden, great. And you could probably get a bigger bit of kit. Got to be careful about blocking the road unless they're going to be very quick. But yes, it would be easier than trying to get everything into the back garden. And if they can just dig a little trench, fantastic. If the property is suitable for that, yeah, that's a good idea.
Nick, have you heard of AOS in Cheshunt?
AOS? No, that's a new one on me, but there are a lot of heat pump companies
They've
around.
come and given me, they've surveyed my house. But
Okay.
now you're worrying me, all this thing about environmentally friendly, because I haven't committed myself yet. And the thing about Legionnaire's disease, I don't know, I'll have to ask them about that. And
Yeah.
one of your people who does the assessment. You know, Trevor Ford, I saw him on the list and he came to me, but I wasn't very impressed with him, to be honest.
Okay. I mean, yeah, if they're working at those prices, maybe they're not impressive enough. You know, I would rather pay a bit more and have someone decent who can help. But
well, he actually admitted he was doing it extra above his work because he wanted to make some money quickly, which doesn't sound very professional to me.
well, at least he was honest.
Yes, I suppose so.
But Legionella is a big problem, so do take that one seriously. The refrigerants are even a bigger problem, but you need the grant to make the thing viable. So as it stands, there are no heat pumps that qualify for the grant that use environmentally friendly refrigerant. I must try and do something about that.
Anyway, AOS in Cheshunt is another.
Okay, I will make.
They are certified and everything.
Okay, fantastic. Of course, that's not East Hart, so I wasn't looking at them.
No, but it's the one that Dick Warren used.
Okay, I will check them out. Thank you.
Okay.
Can I ask a question? Would you agree that if everyone in the country swapped their gas-fired boilers for a heat pump of some description, we would mess up the grid?
Absolutely.
Yeah.
Yes.
If everyone went to electric cars as well, we'll mess it up doubly.
So surely we ought to be looking at fabric improvements at the same time.
Well, you'll have to look at fabric improvements anyway if you want to cut your heat loss by 57%. You know, that's a massive improvement in insulation. You know, I've already doubled my loft insulation. I'm not quite sure what I could do to get my heat loss down much more. I'd have to go for triple glazing, I guess, which...
Yeah, well, I'm an architect and passive house designer, so I can do that, but when you're working on existing buildings, I accept that the affordability is a big issue, and sometimes the practicality of it.
Yeah. So yeah, grid reinforcement is going to be a huge issue, but it's going to be a huge issue anyway. If people want to plug in their hybrid cars, and you know, they all want them fully charged for 7 o'clock in the morning for the commute, then we've got a big problem coming anyway. But grid reinforcement is probably a good thing. It's a lot easier to supply green electricity than it is green gas. You know, every scheme I've seen for green gas hasn't impressed me at all so far.
I also take the opposite view to you on EPCs. I would pay the absolute minimum that you get away with because it is useless. It is no use to anyone. An example, I've designed a passive house which actually, with the combination of, it's obviously a well-insulated new building, it's got photovoltaic panels and, you know, nighttime economy from the grid as well. Basically, my client makes just over £100 a year profit. And, you know, it has a very low heating load anyway. But the EPC on that was just scraped into a low B. So, I mean, you know, it's a very efficient building and it's a B.
Okay.
So, you know, to me, that is a reflection on a sort of just a crazy methodology that's just not fit for purpose.
Yeah, yeah. I'd agree. That's probably the case, yeah.
But I would be, I mean, I'm fully committed to not fitting ever fit a gas boiler again on any of my projects. So, you know, the heat pumps are what I'm, you know, pointing clients towards all the time now.
I think, particularly if you're doing new build, it's fairly straightforward. It's the retrofit market that's challenging. If it's a full refit and you can put in underfloor heating, then fantastic. But if you're trying to upgrade people's radiators, particularly from an architectural point of view, you don't want double and triple panel radiators if you can possibly help it. It's there are still some difficulties. Any more questions? So there's a couple have come in on the chat. A couple of people couldn't see my screen. So what I'll do is I'll make this PowerPoint available to people who want it. I can send them that. And Lucy has asked how long the process takes. You'll be surprised how long it takes. You're going to be months from start to finish. So keep your existing heating system in place while you're going through this. In terms of the changeover, if we were changing over from a gas boiler to a heat pump, you would have to do the changeover in one day. You can't leave people without heating much longer, unless you're doing it in the summer, of course, in which case, so you do all the work and then do the changeover right at the end. And if you could do it in summer, it would be more comfortable for you than if you do it in winter. People tend not to think about their heating until they're cold, and the time to think about it is midsummer, of course. But it's if you were the borehole we did in Ladbroke Grove, it took them 2 weeks because the rig was so small, and then we were probably 2 weeks. It was a new build, and we were probably 2 weeks fitting out the heating system. So it's yeah, these things take time, unfortunately.
But an air pump is quicker, yes?
The air source go in much quicker.
That
And
can be much.
if you're putting it onto an existing system and everything's ready, you could do it in a day. But they're not as efficient, and they do need to defrost. And the typical UK winter, it's not when it's below freezing that problem is. It's when you've got high humidity and you're about the 3 to 5 degrees centigrade, and these things ice up so quickly, and it'll be defrosting once an hour under those conditions, and you lose all your heating during the defrost cycle.
Ooh.
And we're out of time, so I think we should all say goodnight, go and have some dinner.
Yes.
But I will make this presentation available to anyone who wants to see it. And if anyone's actually going to put in a heat pump, do contact me. I'm quite happy to give free advice to all Green Party members.
Thanks, Nick.
Thanks very much.
Thanks,
Really
everyone,
helpful.
and
Thank you.
do have a good evening.